Alright, so on the bench today I have two non-working U5000s. These are both the 25-inch version, and the U5000 is a dual res. You can see there's a connector here for 15 kilohertz or 25. These came out of Cruisin' USA machines that were not working, and obviously they didn't work properly, so the seller took the chassis out and swapped them with other working chassis. And I have no neck boards, I have no neck board harnesses, I have no remote harnesses for either one. All I have is just the main chassis, and that's it. So what happened was the seller took working boards and took the neck boards and such off of this stuff and put them on the other ones. So basically this is all I have. Fortunately, I have all the spare missing parts. I have spare neck boards, I have spare harnesses, I have spare remote boards, all that stuff. So I went ahead and bought these in non-working condition. I think I paid $40 for both of them, so 20 bucks a piece. And giving them a good look over, I can already tell you they have issues. So we'll just do one at a time. I'll get the camera set up on the overhead, and we'll just give it a cursory look over for damage and stuff that could be the cause of them not working before we really do any actual testing. So I'm going to get the camera set up on the overhead, and we'll go through, let's just go through this one first here. I'll put this one aside, and we'll go over this one, so stand by one moment here. Alright, so giving it a good look over here, we can already see that R728 is quite toasty, and so that's definitely an issue. And everything else seems to be visually okay. There's no missing components. This here is just a pincushion board. Do I have it looks like this. One moment. It looks like this. Now you don't need this. All this does is this hooks onto this connector here, and it'll allow you to adjust your pincushion, your square image, if you will, if you're not familiar with pincushion. I don't really need those. It just makes the image round as opposed to square. That's all that's for. So anyway, there's no missing components. There's nothing else really burned. This coil here, this inductor actually is kind of charred, but that's not out of the norm, so I'm not really worried about that. Basically all there is this R728 is kind of charred, so we'll test that and see what that reads. It should read a 1 k ohm if I'm not mistaken. So we'll see what it reads in circuit. But everything else is intact. Obviously it thinks somebody has replaced some of these capacitors in the past, because that's not how it's supposed to be. If you look at this one, this is how it should look. And so somebody obviously has replaced some of these capacitors in the past. So we'll move along here. Everything else seems intact. Nothing is missing. So let's just do some basic troubleshooting. This was obviously advertised as not working, and I imagine so because of that burned up resistor and whatnot. So as things go, we'll test our HOT first. Make sure it's not shorted, because that's usually the case with these things. I can get a little bit more involved. Right now we're just looking to make sure it actually powers up. And off camera I did already make something, or a quick repair. There is, on the U5000, there is a secondary little device here that's normally screwed to this heatsink. You can see on this one it's attached to the heatsink with a screw and a nut and whatnot, but on some of them don't have that. The earlier models didn't. So all this is just a circuit that allows you to select 15 kilohertz versus 25. I believe for 15 kilohertz you have to have this little jumper hooked up to the pin, and for 25 you want to have it disconnected for 25 kilohertz and connected for 15 kilohertz. I may have that backwards, but that's what this is, depending on your selection as well on this jumper connection here. So that's all this is. But basically someone had cut the wires. I can't tell you why, but they had cut the wires. I went ahead and just repaired that because that was the first thing I saw. So that was something I did off camera. But with everything looking okay, we can look at the back side, and nothing jumps out at me. Nothing's charred or you know, zapped or burned. Everything looks okay. Nothing too bad. So we'll start by checking the HOT. I'm assuming it's going to be shorted because it's not working. Usually that's the case with these. And there's a couple ways we can do this. We'll put our meter on the diode checker, and we'll go to the center leg of the transistor, and then we'll touch the base and the emitter. I'm sorry, the collector and the emitter. Oh, that's good. 467 and 467. Hey, well, that's interesting. HOT is actually good. We can test our voltage regulator. Well, there's many power circuits on this thing, but for our purposes, the voltage regulator is this guy here. So to make it a bit easier, we'll touch this for the base, and then we'll touch this leg here if I can reach it. It's hard to get in there. There we go. Let's do it the old-fashioned way. Let's just go to here. Alright, so here is our base. And we'll go to our collector. That's good. And our emitter. Good. Alright. I made those backwards. I don't know the specifics, but it's one's the base, or I'm sorry, the base is the center one, and then the outside legs are the collector and emitter. But basically you can see that check's good. That's not shorted. The other leg is 1 point something. So that's correct. That's a good reading. So our voltage regulator IC is good. Our HOT is good. Something else that can keep this from powering on is the switching mode power supply chip, which is this guy here, SMPS. It's a switching mode power supply chip. An easy way to check that, to make sure that's not bad, is again, we're on Diode Checker, and we want to go the side here with the power supply section away from you, and we'll go to, let's see, I can zoom in a bit. These two pins here, there's 8 pins here. The very outside pin and the one next to it should read like a diode, just like that. And then we move our leads over to these sets, or this 2 sets here, or this 2 pins, and this should read the same thing, roughly. That's good. These 2 should read open. Well, maybe not. Depends on which way you have it. I thought that's supposed to read open. Well, either way, that's actually not bad. I'm looking for a short, so okay, yeah. So it depends on various factors. So I guess it's not supposed to read open. I thought it was, but either way, regardless, it's not shorted. So disregard that. These 2 pins, I believe, should read 1 point something or other. Yeah, there you go, like that. So our switching mode power supply chip appears to be good. So there's only one thing left in the circuit that can cause it to not power up. If our switching mode power supply system is good, and our voltage regulator is good, and our HOT is good, the last thing standing is basically this transistor right here. If you look at the chassis there, I'll back it back out here. Over here, there's a transistor here. It's Q703. If that's open or shorted, that will kill the system as well. And something else to note is that it actually is on the same circuit. If you follow it along, this resistor that's burned up goes over and goes through this transformer, and the output of the transformer goes through and over straight to the emitter of this transistor. So that could have something to do with it. So we'll check Q703 here, which is, let's zoom in here, which should be, let's see, it's right here. It should be, I'm trying to look through the camera while I'm doing this, so I'll look at the actual board here. So it should be these 3 right here. So if we go to our diode checker, and we'll test center, negative, and emitter. Oh, hey, open. Let's try and get this in frame here. That is open. What about to the other side? That is open as well. Just for shits and grins, we'll swap our leads around. Still open. That is not good. You can see here that we're on our base and we got nothing on the emitter and we got nothing on the collector. That may be our culprit. And just for show and tell here, I'll see if the other one reads good. So here we have the other one, again, Q703. Let's turn it around. It's right here. Let's turn it around, which should be these 3 right there. And we'll put our negative on the base, and we go to our emitter. That's emitter. That's our collector either way. Yeah, see, there you go. See, that one reads good. 0.624. Other way. 1.2, that's correct. So yeah, apparently that's the issue. Well, hopefully. So we'll set our other one aside here, and I'll have to see if I can find a donor R728 and a donor Q703, and we'll replace those. And then I'll grab my spare remote board harness. Let's zoom out here. And I'll grab my spare neck board harness, a neck board and remote, and I think that should be it. Our neck board connections are intact. They're cut on the other one. Yeah, so I'll get those two components replaced, and then we'll hook everything up and we'll see if this works. So stand by one moment. So here's a spare chassis I have. It's a spare U5000, and as you can see, it's seen much better days. This occurred during shipping, so I've actually used it to rob parts already. You can see that there's a couple ICs missing from previous repairs. But yeah, this actually had been recapped as well, so I may steal the caps from this to use on the other one. I don't have a cap kit, so we'll see if we can get it running first. But the basic thing here is that I've actually got a Q703, and we'll test it here in a moment, and an R728 right there. So let's actually test these real quick. I forgot to test them before. I'm sorry, I forgot to show R728 testing on the camera here. So let's see what R728 is supposed to read on this chassis. Yeah, well, yeah, about 1K. So if we go to the other one here, it's all burned up. Let's see what it reads. Yikes, 1.3 megohm. So that's coming out. Alright, let's move this out of the way. And we shall pull out this resistor here, which appears to be, that is quite burned up. Look at that. Here is the pad for it. Nice and crispy. So we got this here. Alright. Let it heat up a little bit more. Doesn't like that. That side's good. This solder is so bad. Yeah, that solder's no good. So let's add some fresh solder to that. See if that helps out. Well, no, that solder won't flow. It's too, it got too hot. So let's just clean that out real quick. Let's just heat it up, take it out of there. There we go. All right. So that is out. If the camera would focus there. So we will steal it now from this one. Yeah, that got quite a bit hot. So let's steal it from here now. So I'll tell you what, let's just do it the easy way. Heat this up. Well, I say that, but it's not coming up. There's one side, there's the other. Now, we'll set this aside for the moment, and let's test our other Q703 here. Alright. Wow, this thing got real butchered in the shipping incident. So let's just go ahead and test it here, though. Okay, center base is negative, and we'll go to emitter and collector. Good. Alright, so that's a good donor. So we'll take that out of there. Beautiful. Nice and easy. I always clean this after every time I use it because it gets clogged up pretty regularly. Alright, so now we can set our donor aside completely, hopefully. For now anyway. And we'll take our other bad one out of here. Where are you at? There you are. This may be a bit more tricky. These pads are pretty sensitive. Oh, that survived. Okay. Hey, not too bad. There we go. So there's our bad one. Set that aside. And, alright, you can see that that turned out somewhat okay right there. So let's get our new one in. And you can see it's got the round parts right here, which means the flat part goes that way. So we'll do this here like this. Sorry for the bad camera work. I'm not a professional. I think I'd know how to do this after all these years, but okay, so that's in. Let's turn it around. Hold it in place. And we'll slightly bend our legs here because we don't want it to be too tall. So that should work. And then we'll fire up some solder here. Let it flow, let it flow. All right. Nice, all right. We'll snip our legs. All right, so now let's test it. And what I always like to do, looks like this one's not too, that pad's lifted a bit, but not too bad. Reflow it a bit afterward. Okay. So let's zoom out a bit and then we'll test it. Alright. Okay. Center negative, and we'll go to emitter. Actually, you know, when I do this, I like to go to the next corresponding pad. You can see here that it goes from here to here. That way I know that it's actually a good solder joint. So I'll go to the center, which is this pad. This pad connects to the center. And then I'll go to this pad. Should read, you know, 0.6 something like it should. 0.5. It's hot. The component's hot from soldering, so it's a bit different. But once it cools down, it should be closer to 0.6. So I'll go to this pad. Okay, that's good. So our solder joint there is good. You know, our center solder joint is good. And then for the collector, like I say, I'm too lazy to look up a collector or emitter. It's one of the two, but the outside ones are always collector and emitter. So we'll go to this pad here, and yeah, we got 1.2. Go back to here. There's our 0.6. Yeah, once it cools down a bit. So we're good. Center, 0.6, outer, 1.2, yep. So, good to go. And let's put our resistor in. Alright, zoom out a bit. There we go. Alright. Our resistor is in. Turn it around. Every now and then I get a little bit closer. And we'll throw some new solder on here. Give it some time to flow. That's not too bad. There we go. Not bad at all. Let's check out the joints. Yep, that'll do quite nicely. Okay, well, I think the next step is to get everything connected to it, get it on a tube and fire it up and see if we're successful. If so, this one only had the bad resistor, which was burned up because of the bad Q703. So let's cross our fingers. I'll get it all set up and we'll cut back here with it ready to go. We'll turn it on and see what happens. I just wanted to show here before I get everything hooked up that I actually do have, you know, the extra neck boards and the extra harnesses and remote boards and stuff from things like this that get damaged over the years in shipping. So I ended up with extra stuff. So it actually worked out pretty well that I was able to get these chassis for 20 bucks a piece basically. So let's pick one of these at random, you know, here, and let's get it on the chassis and see what shakes loose. Well, we're all hooked up, ready to go. I got the chassis on the frame. It's not screwed down. We have our anode cap. We got our yoke connected, both connectors. We got our neck board installed, our DAG ground hooked up, and our video. So you always count to 5 before you power it up to make sure you don't forget something. So we have our anode, neck, yoke, ground, and video. I have to switch the connector over to the 15 kilohertz so I can actually test here on the test rig, because I don't have a 25 kilohertz board. I do have a test pattern generator here somewhere. There it is. But I'm only going to test, well, I could probably test 15 and 25, but for now we'll test 15. So we're all set up, ready to go. In the connector here, you'll see that there's an actual diagram on the original U5000 frame. You can see here that the jumper should be connected for the 15 kilohertz and not connected for 25. So in this case, if you're running 25, you want to have this unhooked. But since I'm going to run 15, I want to hook this back up. So there we have it. So, yep. Oops, sorry. I did have it. And that's harder than it seems. There we go. Okay, sorry about that. Alright, so we are ready. Actually, you know what? We're not ready. I have to hook up a PCB here. One moment. We'll hook up good old MK1. Get this out of the way and this out of the way. Set this down. Well, fingers crossed. What do you think is going to happen? We're all hooked up. I got my remote board connected to the correct position. Got our neck board hooked up, our neck board harness and wiring. So, yeah, fingers crossed. 1, 2, 3. It did not come on. I got power hooked up. I don't hear anything ticking. Well, so much for that. Back to the drawing board, and we'll see if I can figure out what's going on now. Maybe it's bad caps. We'll see. Stand by and I'll see what I can figure out. So there's a couple of things I forgot to go over when I was talking about everything that can cause the chassis to not turn on. And I forgot to mention that the flyback most certainly could keep the chassis from powering on. And there's also this IC over here, U701. If U701 is bad, it can also keep the chassis from firing up. Now I went through and tested every single pin to a working U5000 and compared the readings, and everything is good. The last couple of times I had to change this out was because it had multiple pins that were shorted to ground, as opposed to just a single pin that should be, you know, a ground. This one actually checks good in comparative readings to the other one that's in another working U5000, so I'm going to rule that out for now. We may end up changing that out as a last resort, but I went through and double checked everything else. The voltage regulator, the switch mode power supply chip, the HOT, all the diodes in the circuit here up front by the HOT. There's some diodes here that can go bad, that can cause it to not fire up. Those are good. Every other diode I checked is good. The transistors and the the capacitors here next to the switch mode power supply chip, everything that can normally cause it to not turn on checks good. And actually you can't hear it on camera, but when you try and fire it up, you can hear it humming. So it's trying to fire up. It's not ticking, it's trying to fire up, but it's just something is keeping it from doing that. So I think I'm going to replace the flyback just to see if that's the cause. I got a brand new one right here. I'm going to install it, and if it doesn't work, we'll go ahead and just leave it in, and I'll put this back in the box and have it as a spare since it's not the cause. And if that doesn't work, we'll go ahead and just do a whole cap kit. I've got an entire cap kit here, along with the filter cap. So if the flyback doesn't turn out to be the issue, we'll change all the caps, even though the caps all look okay. That some of them have been replaced, some of them haven't. But they all look okay. None of them are leaking, none of them are in terrible condition, none of them are bulging. So I don't think it's a capacitor issue. Could be, but I can't rule it out. But I think it's probably more related to the flyback. So let's remove this flyback and put the new one in and see what happens here. So I'm going to turn on my equipment. In the meantime, I'm going to disconnect all this ancillary stuff so it's not in my way. I don't generally like to turn this over and around and move it up and down and everything with all this stuff connected, because you can create broken solder joints, and you can mar up your neck board and bend this stuff all up and get it all out of whack. So I like to just disconnect all the ancillary stuff, the remote board, neck board, all that stuff, while I'm doing all this work to the main chassis. There we go. Just waiting for this to heat up. Okay. Back up just a little bit. Okay. And the desoldering gun makes quick work of this. I did go through and look at the entire bottom of the chassis and reflowed various suspicious pads, but I didn't see anything that would jump out and go, oh, there's the problem. So it all looked okay on the bottom. So we'll change this flyback out and see where we're at. That could be close enough, so let's put that on here, let it heat up. That should be sufficient. This one might be a bit harder with the giant ground plane here. I'll just heat that up with the iron. Alright, so let's clean this out. Okay, set it back in the holder. Let's get our iron here. There you go. Easy as pie. Pretty simple. So let's set this one aside and get this one out of here. Okay. Now comes the fun part of trying to get this to sit in here, especially with that ground. That should be good. There we go. Okay. Now we got to try this again here. Ooh. Sorry about that. Bumped the camera. Got it. Well, if this darn thing... Man, I tell you. These stupid clips here are going to go bye-bye. Now let's see it. Give me grief. You know what? Let's do this. Okay. Let's try this again. That was much better. Stupid plastic clips always give me grief. Okay. Now let's zoom back in here and flow this up. That should be okay. And I'll of course come back and clean this up later. For now, I just want to see if this gets it going. Alright, that looks pretty good. Alright, so all these flatbacks come, when they're brand new, they come with the screen pot turned all the way down. So you want to turn it up about maybe a quarter, just so you have some kind of brightness or image when you turn it on, if it does work. So, and again, when you get these flatbacks, the thick wire is the focus wire. So the thick wire is always going to be the wire that goes to the neck socket, and the thinner wire is always the one that goes to the G2. The G2 is this pin right here, but let's see, I'm going to have to cut this connector off of this one and splice this wire on, which I'll do that later. For now, for testing, I'm just going to solder the wire to the back of the G2 pin. I'm just going to solder the wire to the back of the G2 pin. So, but again, the thicker wire goes to the focus pin, which is right here. Make sure it's lined up and you don't smash a wire when you get it in there. There we go. Hook it around. And let's add some solder to this G2 pin. Right here. We'll just put this on here. So again, this is just for testing. I'll do it properly at a later time. So there we go, and zoom back out here. Alright, plug this back in, plug our remote board back in. Alright, let's get it back on the tube and fire it up and see what happens. If this does not work, I will do a full cap kit. I'll cut away, install all the caps, come back, and then we'll try it again. So I did check this coil here. This coil is a bit burned up. I did check it. It's good, so there's nothing wrong with that. And like I say, I went through and tested I went through and checked all of the solder joints and reflowed anything that looks suspicious. It's all good. Did nothing anomalous there. Checked everything else that I could think of except for replacing this chip and the flyback. So let's get it powered up and see what happens here. Alright, ready to go. We got our anode neck board, got our yoke connected, both connectors, we got our DAG wire hooked up, and our video. So count to 5. Let's turn it on, see what happens. Fingers crossed. Nothing. Damn it. Well, okay, I guess it's full cap kit time. Then we'll see where we're at after that. So stand by here. Well, we're at a different position than we were just a few moments ago from your perspective. I did a full cap kit and it did not fix the issue. It still was dead. Now, I've leapt forward and did a bunch of stuff off camera. As you can see, I have a bunch of components sitting over here. They're all bad. I'll get to that in a minute. But this chassis repair is fixed now. And I did all that off camera because it was going to be easier for me to just go ahead and try and figure out what was wrong than make a 3-hour-long video. So this is already kind of long enough as it is. This tested my entire ability of patience and repair capability, if you will. This put me to the test, and I've conquered it. But man, I tell you, this was something that I wouldn't have to wish on my worst enemy of trying to figure out. Okay, so let's review here for a minute. We started out where it was completely dead. It was making a faint noise, but that was about it. So we did the normal things. We did testing of the HOT and the voltage regulator and the switching mode power supply IC and a bunch of stuff. And everything checked good, except for this transistor. This transistor was open, and it was Q703 if I recall. Yeah, Q703 up here was bad. We changed that out. It didn't make any difference. And what was it? R728 was also bad. R728, which was over here right there. Changed that out as well. No change. No difference. So we did the flyback. Didn't change anything. I did the cap kit. Didn't fix anything. So it was kind of back to the drawing board. And I did the power supply test where you use a light bulb to check the power supply. What you do is you raise this leg. It's hard to see, but there's a resistor right here. It's R7, what is it? R100. R100 right here. You lift this leg that's right here by the horizontal width coil. You'll take that leg out of the circuit and you run a jumper wire to the tip of your light bulb, and then take the ground and just touch to a, I just used the heatsink here. Bulb did not light up. So then I knew I had a power supply problem, which is this section over here. Based off of that, I found multiple bad components. Let's see here. I don't know if it has it's probably covered up, but this ceramic resistor here, supposed to be 10K ohm, was wide open. Nothing. It was open, no reading. So it was bad. C106 was also open. I changed out to a different type, but I robbed it from another U5000, so it's still the same voltage rating and capacitance and everything. It's just a different type. So C106 was open. C112, this little guy right here, it was open. After that, I had my light bulb lit up. So that fixed my power supply problem, but it still wasn't working. It was no longer dead, but you could hear the transformer here hissing, trying to do some stuff. So the transformer was hissing, but with the light bulb lighting up, I knew that my power supply was good, and my B plus was at 180 volts. When I hooked this up, it lowers it down to was 134 or something, which was still a bit high, but at least I knew that my power supply section was good. So that led me to a problem in the horizontal output circuit. Now I knew that my HOT was good and everything else was good, so I started poking around in the horizontal output section, which is this whole area on this side. Well, actually, this is vertical. It's a combination of all your vertical and horizontal outputs basically on this side of the chassis. So going through and testing everything, I found two resistors that were open. I had to go component by component using a working chassis until I found the problem. R765, which is this blue guy right here, and R760, which is this taller guy right here. This resistor and these two resistors here were both completely open. And that's these two here. These two resistors were wide open. So I had in total I had 1, 2, 3, 4, 5, 6, 7 open failed components. All those guys right there were all bad on this chassis. The reason I found these two was because, let me go back, I forgot. After fixing the power supply section, I initially found this resistor open, R760 was open, so I changed that first. After doing that, I powered it up and the HOT blew. So I said, oh, okay, I'm making progress. At least, HOT blew, not good news, but at least I'm making progress. After going back to that same section, I found that R765 was also open. After changing that out, chassis came to life. I haven't made any adjustments. I turned it on, I got a picture, and turned it right back off. So then I turned on this camera to make the video. So the chassis is now repaired. We need to hook it back up to the tube and adjust our B plus and get everything looking good and making sure that it's working for 15 kilohertz and 25. So you can see I have it set for 15. 15 is the left side, 25 is the right side, and then I have the connector hooked up here for the 15. Now this is a vertical sweep mod is what this is. It's to improve the vertical sweep of the image. So that's what this is actually. But some of the U5000s don't have this, some do. Most of them do, some don't. Anyway, so that's the story of this. It's now repaired. And man, this was just, it took me all of yesterday and all of this morning to really narrow down. So now it's been tackled. And I should have had the camera rolling when it turned on because I'm the smartest man alive kind of thing. But yeah, so I got this working. This was quite the head scratcher. I wouldn't wish this on my worst enemy. The U5000s are real hard to, are plagued with issues that are real hard to get going. But I got this one done. I got one more over here to do after this one, so stay tuned for that. But we'll get this hooked up to the chassis. It's all reflowed, new flyback, new caps. Most likely the original flyback was just fine, so I'll keep it as a spare. No reason not to have a good one, or not a good one. I'm sure the other one was good too. I'm sure there's no reason to have a replacement in here. So yeah, we'll get it on the tube, and we'll get the B plus adjusted. I'll show you how to do that, and then we'll do all the adjustments and make sure it works for 25 using the test pattern generator, and we'll call it good. So I'll cut away here hopefully one last time, and we'll see how it turns out. Alright, so we're hooked up on the tube. Everything is reinstalled the way it should be. And how you test your B plus on a U5000, it's in different locations depending on 7400, 7500, and U2000 and so on. But on the 7500, right here, TP202, if I get this stuff out of the way here, there we go. TP202, there's a little test point there, and you can see I've got my plug on there. There you go. See, there's a little test point there. We'll put our lead on there, and the B plus pot is right here where it says B plus adjust. Now you see there's a bunch of glue on there. Sometimes you can take a pair of diagonal cutters, flush cuts, and kind of cut away at that glue and free it up without damaging the pot. That's what I did here. But I have not adjusted the voltage yet. I have not made any turn. I cut the glue off so I made sure it was free and put it back where it was. So it should be 117. If it's not, we'll just turn that pot until it's 117, and that's how you adjust your B+. So let's turn it on, and you guys can hear it fire up for the first time here. Well, I already had it on, I guess, so the tube was already energized, but hey, look at that, 117.2. I don't need to adjust anything. You got your, make sure you, when you're doing this, you want to have your positive lead somewhere where it doesn't arc to the frame. You'll be right back where you started. And we got our ground hooked up to the frame here, so yeah, look at that, 117.3. You don't have to adjust anything. Perfect. That worked out. So yeah, that's how you check that. So now let's get this turned back off. And we will remove our little clip lead there and this clip lead, set our meter aside, and get rid of my supplemental light here. And let's turn this sucker around. We're all secure, we're all hooked up, it powered up. I have not adjusted anything yet. See if I can do this one-handed. Yeah, somewhat successful. Okay, let's hook up our video signal. And we'll use our MK1 as a test bench here for our standard 15 kilohertz. And hopefully this works. Zoom out, there we go. Oh, my contrast and brightness are turned all the way down as a preemptive setting. So I may have to adjust my flyback here a bit. Okay, now we've got a somewhat of an image. I'll say we'll leave it there. There you go. It's working. Alright, so now we can use our supplemental adjustments here, contrast and brightness. Oop, must have been too high there. Contrast. And those colors are almost good. It's way too high. Oh no, those colors aren't good at all. I need to set this down. Okay. H position. You know what? Let me get this on the tripod. Make it easier for me and you. My camera work isn't always that great, and I apologize about that. Alright, there we go. Well, I'd say that's a successful repair. But man, was it tough. Let's do H position there, right about there. Let's do vertical position, roughly there. We'll do our height. H position again. Let's do our width. And yeah, I'd say that's pretty good. Hot dog, that's a bit too bright though. Turn it down. Turn this back up. Now we need to do focus, which I might have to get in the way of the camera here for focus. Oh, that's glorious right there. Well, I'm not going to spend too much time trying to do color adjustments, because you can see the color is pretty close as it is. And plus it doesn't matter because this chassis is not staying on this tube. But you can see it's pretty darn close just out of the gate without having to do anything. I'm going to turn the green down a bit. Blue up a bit. Red. That's good. Yeah, I say that's pretty darn good. Look at that. Wow. Hey, alright. Nothing left now but to check the medium res. So let's turn this off. And I will swap the connector from 15 to 25. And disconnect the vertical sweep connector. So now we've got, hey, what's up? Hey, we've got our vertical sweep connector disconnected, the little plug on the side, and I got my main connector moved from 15 to 25. Now let's hook up our test pattern generator. And I'll set it for medium resolution. up. And I will turn it on, and let's see if it works. Sounds good. Yeah, see, the problem with medium resolution is the settings are so vastly different for size and position and screen and everything. But let's see if I can get some color bars here. Yeah, see how I'm missing red? I'm not actually missing red. I guarantee you if I shift this over to the right, the red will come right back. Each position. There you go, see? It's just so vastly different between the resolution settings. Height. I got a little gouging in the corner, but that's not a big deal. Width. So yeah, there you go. I got vertical, I'm sorry, I got 15 color and 25. We got a successful repair, guys. So thanks for watching. And I'm sorry the video was so long, but it was worth it in the end. So hopefully this helps somebody out in the future. If you got a U5000 that's got all kinds of issues, maybe this will help you out. That's the whole purpose of this. I hope so. So comment down below, subscribe if you're not subscribed, and I appreciate you watching.